Last episode, we calibrated the risk score. We made a 0.9 mean a real 90% chance of attack, so auto containment could trust the number. But calibration assumes the world stays still. It doesn't. The day you ship a phishing detector is the day attackers start studying it. Our episode 2 house model launched near PR AOC 0.99. The question nobody asks until it hurts: what is it today? This episode we let 8 months pass and watch a frozen model rot. Misconception number 1: train it once, ship it, move on. A detector is not a bridge, it's a contract with an adversary who renegotiates every month. We freeze our month 0 model and never touch it. By month 8, its PR AUC has slid from 0.984 to 0.875. That's not a bug. That's the only thing that can happen when the thing you model fights back. This kills the misconception that accuracy looked fine, so we're fine. The slide is invisible on a dashboard that only shows today's alerts. The model still fires, still produces scores, still looks alive. The rot only appears when you remeasure PRIUC on fresh recent traffic. No remeasurement, no signal. You don't feel drift, you feel the breach it eventually causes. Why does it drift? Two forces, both attacker driven. The classes blend, phishing URLs start looking more like benign ones as attackers copy legit patterns. Our class SAP shrinks. And the features shift. Attackers pad URL length, push entropy up, so the exact thresholds the model learned now point the wrong way. Same model, moved target. The decision boundary is frozen in a world that has walked off without it. Here's the operational fix that beats panic retraining every week: a floor. We pick a PRIUC line, 0.93, below which the model is no longer fit for the SOC. We don't retrain on a calendar, we retrain on a breach. Month 6, the frozen model touches 0.924, crosses the amber line, that's the trigger. The green line shows the retrained model snapping back near 0.29 and holding. Retrain on the floor, not on the date. And the killer detail: the frozen model didn't fall off a cliff, it bled. 0.984, 0.976, 0.968, 0.959, 0.942, 0.924, 1 or 2 points a month. Any single month looks like noise. Stacked over 2 quarters, it's a 10-point collapse. This kills the misconception that I'd notice if my model broke. You won't. It doesn't break, it erodes. Only the rolling curve makes the erosion loud enough to act on. Open16 concept drift.py, one file, one seeded world, 8 months of it. Make month half is the whole trick. We keep the geometry seed fixed at 42, same EPO2 house world. So this is genuinely our detectors universe, not 8 unrelated datasets. Then per month we shrink class SAP and add a growing drift to the attacker class's features. The half argument gives us disjoint train and eval draws, so a retrained model is never graded on data it memorized, honest forward validation. We trained the frozen model once on month 0 with the standard knobs from earlier episodes: max depth 5, ATA 0.08, AOCPR as the eval metric, and measure its month 0 PRAIUC on a held out half, 0.991 in distribution, which presents as 0.984 the moment real month 1 traffic arrives. The monitoring loop is the heart. Every month we pull that month's eval half and score the frozen model on it with average precision score. That single call is your drift sensor. Plot it month over month and the rot is undeniable. This is the metric the SOC should be alerting on, not yesterday's alert count. The retrain trigger is one if PR's floor on a breach, we refit the champion on that month's train half, fresh current attacker behavior, and carry it forward. No cron job, no quarterly ritual, the floor decides. That's the operational knob this whole episode is about. The figure prints the story in 3 colors: red frozen line sinking, green retrain on breach line recovering, amber dashed floor at 0.93 cutting across, the terminal table, the printed frozen drift line, and the on-screen headline are the same numbers. The committed notebook reproduces every point exactly. So, a frozen detector loses about 10 PR AUC points in 2 quarters, and you only ever see it if you keep remeasuring on fresh traffic. Monitor the rolling curve, set a floor, retrain on the breach, but drift is the attacker changing slowly. Next episode, SEC 17 adversarial evasion, the attacker who knows your exact features and nudges one URL to dodge the model on purpose. We measure how fast recall falls under an evasion budget, then harden against it.